Hello everyone. So last session we have seen that how to insert a node in a single linked list at the beginning, and how to display the linked list, that also we have seen, and we have we have written the C program for that. Today we are going to see the basic concept of doubly linked list, and also we'll see how to implement doubly linked list such a way that we can insert a node at the beginning of a doubly linked list, and then we'll visualize the whole list. Okay, and we'll do it in C programming framework. So let us start. So the topic that I'm going to cover today is the basic concept of doubly linked list and hands-on C programming for inserting a node at the beginning of a doubly linked list, and how to visualize the doubly linked list, that is displaying the nodes of each node of doubly linked list. Okay, these are the points that I'm going to cover. So major thing is the basic concept and how to implement doubly linked list in C programming. So if you have understood the single linked list implementation, then doubly linked list is no big deal. Just some changes you have to do in the code, and it will be done. Okay, so let us see first of all, let us see the basic diagrammatic approach of doubly linked list, how it looks like. So a doubly linked list consists of continuous link records called nodes. Each node contains three fields. Okay, so three fields. So first is that the data part. Every node in the doubly linked list will be having data, and then it will be having a next link, which we can call that the next pointer to the next node, and another previous link also will be there associated with each node, that will be called pointer to the previous node. So if you, and then also it's similar like single linked list, we will be having head node as well here. In case of doubly linked list also we will be having head node. So the detailed description of head node has been covered in the basic linked list lecture session that you can refer, and why head node is important in all this. So that lecture you can refer to understand what is the significance of head node. So this is the doubly linked list. You can see the diagrammatic view. Okay, so what is the difference between single linked list and doubly linked list, and what is the significance of it? One thing is that in case of single linked list, it is like a unidirectional movement, right? In case of single linked list, we can move unidirectionally. We cannot come back. So that facility has been given in, facility has been incorporated in doubly linked list. Each node will be having two pointers. One is the forward pointer, another one is the backward pointer. So forward pointer you can call it pointer to the next node. Backward pointer we can call it pointer to the previous node. So ultimately we will be having three fields. That's why it is called three fields. One is the data field, data part. Another one is the next pointer. Another one is the previous pointer. So this is the basic difference between single linked list and doubly linked list. Now what is the advantage? Advantage is in comparison with single linked list. Advantage is that anytime I can move back from any node, just a step away, right? If I am here, I can just directly come over here because I have this backward pointer through which I can come back. So that is one significance. So coming back from any node to any node, it is very easy for doubly linked list. That facility is not available for single linked list, right? So this is there, and similarly in case of single linked list also the last node is grounded. In case of doubly linked list also the last node is grounded, that is null. Okay, and here also first node, the previous pointer also pointing to the null pointer. So these two things are similar. That means we have endpoints in case of doubly linked list. Okay, but in case of circular linked list we don't have endpoints. I mean, it is difficult to find the endpoint because in case of circular list the endpoint again is connected to the first node. End node is again connected to the first node. But anyway, that is circular list. So this is doubly linked list. So that is one advantage, I guess, we have in comparison with the single links, that anytime I can come back from any node to any node. That facility is not available in single link. So that is one major advantage we have. So previous link and next link, these two main pointers we have, okay, and then data part. So head node also will be there. Similarly, similar like in case of single linked list we have head node. In case of doubly linked list also we will be having head node. So you understood. So mainly we have three parts in case of doubly linked list. So if you have understood that, then accordingly a structure which is the abstract data type, the definition of structure node in case of doubly linked list will change. Change is what? We will be only we have to add another pointer which is called pointer to previous node. Let us call it pointer to next node, and this is pointer to previous node. Okay, let us name it node nd. Pointer to previous node, pointer to next node nxt. Okay, exactly the same xt nd, exactly the same that we have done in C program in case of single linked list. This pointer to there in case of single linked list also. Additionally, we are adding this another pointer which is pointer to the previous node. Is it clear? That means this is the extra element or extra pointer that we are adding, extra field. In fact, we are adding to the struct node. Okay, to the struct node. So this is what the structure will change in case of doubly linked list. Okay, and head pointer we have already head pointer which is of struct node type. So this thing also will be there in case of doubly linked list. Okay, so I hope you understood the basic architecture of basic construction of doubly linked list. It has every node has three fields: data, pointer to the next node, pointer to the previous node. Okay, what is the advantage? Advantage in comparison with the single linked list, it can come back, it can track back anytime. That is major advantage we have, which we don't have in case of single linked list. Single linked list only unidirectional movement we have. Okay, and remaining the last node is grounded. Last node, the pointer to the next node is grounded, that means null, and the first node also grounded. First node previous pointer also grounded. These two things are similar to the single linked list. Okay, we don't have any problem to identify the end of the list. Okay, which was there in case of circular list. It is in circular list is difficult to identify the last node. Okay, so this is the programming, C programming, that we have done for single linked list. Now let us see what are the changes we have to make. So that it will fit for the doubly linked list data structure also. Okay, so thing is that, as I told you, that struct node, these two header files will be as it is. This struct node, another extra element will be there which is called pointer to the previous node. So here ptr. Okay, and then similarly we will be having the head node. Head node is also there. Okay, head node is also there. So how this insertion function will change in case of doubly linked list. So insert beginning, here also we are actually going to add a node in the beginning of the doubly linked list. Okay, so how this insert beginning, this function will change. Okay, that let us see. So at beginning, so this program we have written earlier, we have written for single linked list. Now let us see how it will change. So struct node, this pointer, this will be as it is. Okay, and there is nothing, no need of changing this, because this new pointer is for creating a new node. And I told you in all the linked list, single linked list, doubly linked list, and circular list, and then circular doubly linked list, whenever you are going to add the node, we have to create the node outside of the linked list, and then you have to attach it to the existing linked list. Okay, so one node has to be created outside. So for that, that node needs one new pointer. Okay, alongside this new pointer also, this new pointer will actually holding the data. It will actually mainly for the data part of the doubly linked list node that will be creating outside. Okay, and then we will be also having the next pointer and the previous pointer. Okay, so this data, int data, and then new pointer. This is the way we are actually typecasting using malloc function. That means one space will be created for this new pointer, where we are going to create the extra node that will be going to be attached to the existing doubly linked list. Okay, so how the changes will happen if if this new pointer is null, then nothing is going to happen, like we can't insert anything. This is like new pointer equal to null, then nothing can be inserted. Okay, it is null. Else what we have to do, else the value that, what are the changes we have to make some changes. Okay, so else what value you want to insert it, so we can put one printf statement over here. Okay, and we can write that slash n, what value you want to insert at the beginning. Okay, slash n, sorry, okay, what value you want to insert at the beginning. And let us say I am just I'm taking the value, and here this is the data that I'm going to insert. Let us say my data value is 8. I'm going to create a node which I'm going to attach to the existing doubly linked list. That node value is nothing but 8. Okay, so that 8, so that 8 has to be taken as a dynamic input. So here you can write scanf function, similarly scanf, okay, scanf, and then percentage d, okay, and then ampersand let us say data, okay, ampersand data. That is all. That is, now this is the data part I have taken over here. Now data part has been taken. Now, but the thing is that the situation is something like this. When I'm going to create a node and I'm going to attaching to the existing link, the situation outside of the list, it will be like this only. Like I have a node. In case of doubly linked list, I have both the pointers. Let us say this 8 I'm taking over here. Okay, value that I'm going to insert is nothing but 8. So this previous pointer has to be 0, null. This next pointer also has to be null. So both these cases will be null, because I told you all the linked list operations we have to create the node outside the linked list and then we have to attach it. This is the situation. So 8, this is also null, this next pointer is also null, previous pointer is also null. So that part you have to incorporate over here. Okay, that part you have to incorporate over here. So how to do that? Let us say, so in this case, let us say data, and then if head equal to null, let us say if head, initially let us say head equal to null, head equal to null. Null is a macro. stdi.lib.h is responsible for null values, all the macro values. If this is the case, if head equal to null, then this is new pointer is equal to, if this is new pointer is equal to null, and this is head equal to null. So don't be confused over it. Head value is null. Then we have to do something with that. We have to this new pointer has to be associated with the head pointer. Okay, if head equal to null, that means head equal to null means list is empty. Okay, list is empty, nothing is there. That means the node that 8 value 8, that node actually is the only node in the doubly linked list. Okay, so if this is a situation, then what we have to do? We have to the parenthesis. So here new pointer already we have declared over here. So this new pointer has to be copied over here. Okay, no star. So new pointer arrow operator pointer to the next node. Okay, pointer to the next node is equal to null, semicolon, and then new new ptr pointer to previous node is also equal to null. Okay, this 2 is null. Why it is null? Just now I have shown you, right? Because situation is something like that. This is the node I'm going to create. So this is the value 8 I'm putting over here. So this is null. This is also null. This is 0. This is both are null. Okay. So this we have to incorporate over here. These two sentences we are incorporating this thing only. Okay. So this you understood, right? And then finally what will happen? This new pointer element, the data that we have scanned over here, this scan, the dynamic input you have taken, the data part has to be incorporated. The data has to be fetched. So new ptr arrow element is the member of the struct node, element equal to data. Okay, because that value already is scanned over here, right? So that value I'm putting over here, that's all. Okay, that element. So that means that node has been, let us say here, if you take 8, that 8 has been taken over here, right? And then finally this new pointer has to be adjusted as a head pointer, because we have only one node. Okay, so here you can write that head equal to new ptr. That's all. If this is the situation we have, like if head is null, if this is for this whole four instructions are for if I don't have anything in the, if list is empty. If list is empty, this is the situation. Okay, if list is empty, this is the only one node, the node that I have created, that node only is the node in the doubly linked list. And then it is the situation. Else part has to be changed. Okay, else part has to be changed, so completely has to be changed. Let us say else part will be new pointer new new ptr. So in case of else what will happen? So first let us write, okay, new ptr, okay, element equal to data, that has to be there. That is the first thing, element equal to data. Now assuming that list is not empty, already on existing doubly linked list is there. Okay, so that is the situation. I'll show you graphically how the things are happening, but first this is the data part has been incorporated as an element. Then new pointer new ptr, new pointer previous pointer, okay, previous pointer ptr to pointed to next, pointed to previous node, pointed to previous node, pointed to previous node equal to, that has to be null. Okay, I'll show you, that has to be null. And then new pointer ptr pointer to next node, that has to be, that is what, that has to be head. Getting or not, this is head, because this now the node that I am going to insert, that will become the first node, that will become the head node. Okay, this is done. Next is what, this now head will become this pointed to ptr, pointed to next, pointed to previous node. Okay, pointed to previous node equal to new pointer ptr. Okay, this is just the previous head node has been deleted, and the node that I have inserted, that node will become the head node. To incorporate that, we are doing so. Okay, and then finally head equal to new pointer ptr. Okay, that's all. So this is over now. Else this is over now. We can have one this thing. Okay, we can have one printf statement saying that node has been inserted at the beginning. So node has been inserted at the beginning of doubly linked list. Okay, /n. Okay, that's all, right? And then this parenthesis, and then another parenthesis will come, I suppose. Okay, we'll see that later on. So this is done. Now this is how we should do. Now what is actually happening over here? So null to you understood, null for null, this for this you understood, that both the previous pointer and the next pointer has to be null. So this is also has to be null, and the previous one also has to be null. This is not a problem. Let us say this is 8. Okay. Now if existing list, this is for the node that I'm going to insert in the existing list. So what is happening? So here also I have this 8, and then I have created the node with this. Okay, this is the node has been created, and let us say this is my existing list. Okay, let us say existing doubly linked list. Some values are there. Let us say 7 9, okay, 7 9, okay, 7 9. So this is connected with the forward pointer and backward pointer. This is null, and this is also null. And then initially head node is actually one head node will be there, which is actually pointing to the first node. Now what I have to do, I have to first take this new pointer element data. This is to done. This is new pointer, okay, new ptr, new pointer element equal to data part has been incorporated. This is the first instruction. Next is new pointer pointing to the pointer to the previous is null. So this is going to be my my new node that has to be added. So this null thing won't be existing over here. So this part, previous part will be null for sure, and this has to be attached over here, right? This is how it will happen. This has to be attached over here. So but this previous pointer will be again null, right? Nu double L. So this is done here, and then this new pointer ptr pointed to this is I think ptr, okay, ptr only one t, okay, that I will see later on, pointed to next node. This is the head node, because this is the head node, and this pointed to the previous node, new pointer it becomes, okay. So this becomes the head node. So head node is nothing but, so this head node connection will be gone. This head node will be actually being attached to here, this thing. This is the head node, right? This pointer will become the head node here. This is how it will happen, okay. So meaning is that the new data, that 8 I'm going to insert, this 8, this will be my head node, now current head node, okay. That is the meaning, okay. So this next pointer will be acting like a head node, head pointer, okay. That will be the head pointer and also the next pointer. So that is there done, and then finally head will be the new pointer. So this is how it will happen, okay. You understood, right? So this is done. So now how this show the list function will change actually, that you have to see. So show the list function. Show the list function, if you see, it is not that much it will change. It will again, if new pointer is show the list, here you can write printf new pointer, here you can write that printf show the nodes of the linked list. One printf you can attach to one printf you can actually have printf printf /n show the list, show the linked list, doubly linked list, okay, doubly linked list, show the doubly linked list /n, okay. This is one statement you can add just for the sake of it will look good actually, right? Now if, and then new pointer is head, this is there, no issue. And then if new pointer is null, then if new pointer is null, then we cannot display anything again, okay. Otherwise inserted value in the linked list, it will be like same only, new pointer element and then this. So it will like, it is like every time it will display the values, that's all, okay, display the values. So here you see this part what this is, unless new pointer is becoming null, all the nodes value will be displayed. So this is after creating the so bidirectional, okay, like that. So is it null? No, it's not null. So it will come to the next. Is it null? No, it's not null. Is it null? No, it's not null. So if next pointer is null, then it will stop. So everything will be displayed, all elements will be displayed. So 8 you have displayed over here, 8 will be displayed, and let us earlier 12 and 13 your display, okay, 12 and 13 everything will be displayed like this. So this is how the doubly linked list will work. And so let us run this. So finally my program will look like this, okay. So some changes I have just made: insert at beginning, show the list, show the linked list, escape from the menu. So these three options I have taken, which can be incorporated as switch case. Switch case is the other form of if else statement, and then show the linked list, this one function, okay. So option one is that case 1 is that insert at beginning, option 2 is show the list, and option 3 is just exiting from the main menu, okay. So if we run this, let us see whether it runs or not. So if node has been inserted here, we can write node has been inserted at the beginning of the list, Okay, and then this will display all the nodes in the linked list. So this we have done. So let us see. Let us run it first. Compile it. Okay, we have compiled successfully, and then we are running it. So this is my options. This is my choices. Okay, switch case options are there. So insert at beginning. Let us say which option you want. I want to insert value. So this is one. Okay. So what value you want to insert at the beginning? Let us say this list has doubly linked list has not been created. So only one node I am going to insert, which is nothing but 8, as we have discussed. So 8. Let us see. So this is 8 has been inserted. So let us view it. Let us display let us show the list whether 8 has been displayed or 8 has been inserted or not correctly in the doubly linked list. So you see, show the nodes of the list is 8. Okay, show the nodes of the list. So we can write in a different way, but anyway, the nodes of the list is nothing but 8. Only one element is there, which is 8. So this is 8, right? This is 8. Which one is 8? This one. This is 8. So this is nothing but only one. This is only one element that we have, right? This is only, so this is situation is something like that. This is 8. This part is null. This part is null. Doubly linked list is completely empty. So only one node is there. That becomes only one node, and that will be also head node. Okay. This is also head pointer, right? So only one node. Otherwise, again, if you want if again, let us say in the second time, if I want to insert again, do you want to insert? Yes. Let us say I want to insert 12 beginning. At the beginning, I want to insert 12. This is the value I am going to insert 12. So press option, let us display it, let us visualize it. So 12, see 12 has been inserted. Say 12 has been inserted. This is my first node, this is my second node, right? Like that, you can insert any number of nodes. So this is the basic operation of doubly linked list that you have understood. In case of doubly linked list, we have 3 elements or 3 fields in the struct node, which is nothing but the element pointed to the next node, pointed to the previous node, and then similarly we can just change a little bit on single linked list code, and then we can actually achieve the result of doubly linked list. Okay, so I hope you have understood, and then later on we'll see how to delete and how to insert at any position, how to search an element. Okay, so this is a linear list. This is again a linear list. So if number of elements are n, then it will take maybe on time. Okay, so thank you for watching.